Good afternoon. I'm Bill Dembski. I'm going to be speaking on the success of intelligent design. And I want to begin, actually, by going back 25 years to a conference in 1996. It was called Mere Creation. It was at Biola University. And the conference brought together all the key people on intelligent design. After the conference, I was really jazzed about what had happened. I was 36 at the time. And I was talking to two of my colleagues in particular, Stephen Meyer and Paul Nelson, and thinking that by the time I hit retirement age at 65, that intelligent design would have won the day. So I want to talk a bit about what winning the day would look like. And spoiler alert, we have not won the day yet, and I'm really not holding my breath that by the time I hit 65, we will have won the day. I'm 4 years away from that. So let me just say a little bit about what intelligent design is, why it's important, and why you should think that there really is something of intellectual merit, something of substance there. So what is intelligent design? Intelligent design attempts to look at scientific evidence for design in nature. So it's trying to position itself against a very materialistic view of science, which dominates in the academy these days, which sees all of life and all the structures in the world as the result of blind, purposeless material processes. So intelligent design says, no, there are patterns in nature that we can discover and that point us convincingly to a design, to something that's the product of intelligence. Now, that intelligence, is that God? It can be God. I mean, if you believe in God, any sort of traditional view of God, then if there is a God, there is design in the world. So there's a logic there. If God, then design. But where the materialists turn that around is they'll say, well, there's no design, nothing evident, no palpable evidence of design in nature, and so then there cannot be a God. So that's why it really ends up being very important in terms of our worldview. So yes, we are saying that intelligent design is a scientific view, and we then position it against views like Darwinian evolution, saying it's a science versus science controversy. It's not a religion versus science controversy. But intelligent design does have religious ramifications, as does Darwinian evolution. Darwinian evolution says that once first life is here, then it all evolves by a blind, purposeless process of some form of variation and then selection. Things that are more likely to survive, that have features that are conducive to survival, will then be propagated. And that sort of survival, I mean, that it's survival then in a sense becomes the intelligent design substitute, whereas in the past we would have thought that a designer was necessary for some of the structures that we see in biology. Now it's the Darwinian view is that we no longer need design. So that's where it ends up being having these theological or anti-theological implications depending on which side of the divide you're on. So somebody like Richard Dawkins, who is perhaps the best known biologist pushing evolution, is also the best known atheist in the world. So he will have written a book, The God Delusion, sold over 3 million copies, and he will argue in another book that Darwin made it possible to be an intellectually fulfilled atheist. Stephen Jay Gould, who was an evolutionist who passed away about 20 years ago, he remarked, ever since Darwin, we know that we were not created in the image of a benevolent God. So these are implications that are being drawn from the scientific theory. Somebody like Lee Strobel, who's written a wonderful set of books where he interviews key people, thinkers on various subjects. He's written The Case for Christ, The Case for Faith, but he also has written A Case for the Creator. And there he describes how he lost his faith as a high school student because of what was called the Miller-Urey experiment, where you basically zapped some chemicals with electricity, boiled it in certain ways, and out popped certain constituents, certain basic things that are required for life, certain proteins or amino acids, I should say. For him, when he learned of that experiment, it was like, well, I guess the origin of life does not require any sort of intelligence. And he lost his faith as a consequence of that. Now, there's an interesting irony just for me personally. When I first looked at the origin of life, I had become a Christian without, my dad was a biologist, he taught evolution, but evolution wasn't the key consideration for me in becoming a Christian. It was the incarnation, knowing that God had become human in Jesus Christ. That was really what was key. But as I started reflecting on evolution and the origin of life, it struck me that just by getting these basic building blocks of life, you haven't really explained anything. I mean, if you give me bricks, conduit, electrical wires, all that stuff, and just pile it up, you have not given me a house. You know, it still requires design. It still needs to be put together in a coordinated fashion. And that was what was, to me, completely unexplained at the origin of life. So nonetheless, when people think that life can come about without the need for any sort of intelligence, it leads to a loss of faith. And I think Richard Dawkins did get it right in saying that Darwin, I don't know if I want to say intellectually fulfilled. I think Darwin's theory has a lot of problems, and we can talk about that a little bit. But he did make it much easier for people to embrace atheism. So anyway, just to back up a little bit. So intelligent design. If I had to give a one-sentence definition of it, it is the study of patterns in nature that are best explained as the product of intelligence. So not mindless material forces, but patterns in nature that are explained as the product of intelligence. Now, my own work in this area focuses on the statistics, the sort of mathematics behind how we detect design. And I can give you a basic idea of that very simply. We all have intuitions about what's within the reach of chance and what's outside the reach of chance. So if I flip a coin 10 times and I tell you I got 10 heads in a row, do you believe me? Well, it's about a 1 in 1,000 probability. What is it? 2 to the 10. So yeah, it's about 1 in 1,000. But I'd say, well, yeah, it could happen by chance. Now, it could also happen that what I did was I actually went into a back room and flipped for about an hour and just waited until I got that 10 heads in a row and then approached you. That's called a file drawer effect, where basically you remove all the negative results, you put them in a file drawer, and then you report the positive results. And that's actually a big problem in science these days, these file drawer effects, where people claim that they got some significant result when they really didn't. But let's imagine instead of 10 heads in a row, 100 heads in a row. Is there any file drawer big enough to collect all the coin tosses so that I can report 100 heads in a row and legitimately? I mean, if every human being as long as humanity has existed, we're doing nothing but flipping coins, one coin a second, one coin every millisecond, throughout human history, it would still be highly, highly improbable that you get 100 heads in a row. So we have these sorts of intuitions about things being highly improbable. Now, with those 100 heads in a row, you might say, well, but highly improbable things happen. I mean, any coin flip, anything, if I flip a coin 100 times, any one of those coin flips is going to be highly improbable. So it's not just brute improbability, it's also that there's a pattern. In this case, it was this very simple, easily specified pattern of 100 heads in a row. One way I like to illustrate that is, if you imagine an archer in front of a wall, let's say the wall is, 50 yards, and you have the archer shoot at the wall. Now, if the archer shoots at the wall, the arrowhead, that point is very small. The wall, let's say, is very large. So the precise probability of that arrow landing any place on the wall is going to be highly improbable. But if I now put a target on the wall and I keep hitting the target with the bullseye, that's going to suggest that I am a skilled archer. To say, well, it just happened by chance, is not going to be an adequate explanation after a while. Now, if the target is movable, if I shoot the arrow, and then I paint a target around the arrow, that doesn't tell me anything. It's still improbable, but it's not that there's this match. There's this pattern match. And that's what ends up being key with intelligent design. It's these pattern matches. It's like seeing a cloud formation versus somebody who's done some skywriting. You see there are patterns that you're not going to be able to explain as the result of chance. And we have there are many special sciences that are already doing intelligent design in that sense. You consider, for instance, SETI, the search for extraterrestrial intelligence. There are signals coming from outer space that could potentially tell us that we were dealing with an alien intelligence. Now, nothing like that has actually happened, but it could potentially happen. If aliens were visiting Mount Rushmore, even if they didn't know anything about us, they could figure out, hey, this must have been designed, because if they're doing archaeology, let's say humanity has disappeared, they could see, oh, there are these the archives, some digital archives with the faces of Teddy Roosevelt, Abe Lincoln, Thomas Jefferson, and George Washington, and they'll see these matches, and they'll say this could not have been the result of wind and erosion. So we know about the difference between patterns that are the result of intelligence and those that are not. And what we're saying in the intelligent design movement is that these same forms of reasoning, which we use very reliably in lots of areas, that they apply with great force in biology. So let me just give you, if I had to give you just one, the key example, if this is the only evidence you could use for intelligent design in biology, I think it would be this, and it's the genetic code. We all know about information, digital information, and we live in a world of digital information. But digital information isn't just static. It just doesn't sit on your computer screen. You're going to write emails, and that information travels. And when information travels, what's needed for that is a code, because it takes on different forms as it travels. It's the same information in some way, but also it's going to be coded in different ways. Now, what's interesting is that the theory of this coding of digital information was done by an MIT mathematician named Claude Shannon in the late 1940s. Watson and Crick look inside the cell and discover the double helix structure of DNA in 1953. Shannon publishes his seminal articles 1947-48. Watson and Crick do that work in 53, but they know the structure, but they're not sure how this is an information-bearing molecule and how information is being transferred. That's elucidated in the next eight years. So by 1961, we know that there's this genetic code, that there's this way of taking three DNA bases and translating them into a single amino acid and then stitching amino acids together to form proteins. Proteins are perhaps the most basic things inside the cell that do all the work, whether individually or in combination. So you have a code there. You're coding from DNA to protein. And where did that come from? Now, if you're a materialist, well, it had to have evolved. But it's an incredibly complex system. DNA actually ends up having a much better information density than even our computers in terms of storage, okay? The amount of DNA that's in one of your cells, if you unraveled it, is going to be about 2 meters, 6 feet, okay? You've got 3 billion base pairs there. So, you're talking gigabytes of information in a nucleus that's about 1,000th of the volume of your cell. And if you imagine having a standard fishing line where every, centimeter had 100, 200 base pairs or so, you'd have fishing line that would fill up this whole stage. But the thing is, what happens with fishing line? It gets tangled, and yet there are all sorts of proteins that keep this from tangling and being inaccessible. So that information is there in a very convenient way. It needs to be moved. Information moves, so it's got to be moved to form proteins. One of the keys to that are some ribosomes, which require proteins and RNAs, which are similar to DNAs. So it's a remarkably complex information processing system that's in every cell, okay? So, and here's the problem then. If you don't have that system, you're dead. And if you're dead, you're not a viable candidate for evolution. So you've got to have that whole thing. That's the minimal complexity of this genetic system, which every living thing has, is extremely complicated, and you can't knock it down, make it simpler, and still be alive. So that means that at the origin of life, you have a fundamental problem of explanation if you're going to try to give a materialistic origin of this. And at the same time, there's a code. We've developed codes. And this happens over and over again, where humans invent some structure. It can be mechanical. They're hopping insects, where if you look at how they hop, they're gears that they use to jump up. You can look at under the microscope, and there are actual gears there. So, over and over again, we invent machines, and we find them inside our living systems. We invent, or we discover how information transfers via codes, and then we find it in the cells. And so we have to be engineers to really understand what's going on inside the cell. So why is it such a big stretch to think that there's actual engineering? Why do we have to reflexively say everything is the result of natural selection, where this selection process, the only thing it puts a premium on is survival? If all you need to do is survive, why not just have a very simple single-celled organism and leave it at that? Why does it have to evolve beyond anything like that? Cyanobacteria, they seem to do very well, So it's the sort of creativity that we see in nature. It seems to me intelligent design gives much better voice to that than a materialistic view. So I think we've got a good case. We've got a theoretical case in terms of design detection, which has been developed even further in terms of ideas called conservation of information or evolutionary informatics, where the idea is that insofar as evolution can work at all, it is because there has to be prior information. Basically, the problem, the design problem has to be folded in there from the start. It's not something that you can, it's not that you get something for nothing. And this is the beauty, as far as the materialist concerned. It's kind of a socialism of biology. You get a free lunch. You don't have to do the actual design work. You get the design up because natural selection is so brilliant, can do all of this. And what intelligent design is saying, no, you've got to do the accounting, and at the end of the day, all the bills need to be paid. The currency of those bills is information, and you've got to account for it. And the information the type of information you need to build these systems, you cannot simply get them for free. It requires an act of intelligence. So, I think for me, my work on intelligent design has been personally very satisfying. I mean, I've felt some of the most creative times in my life have been working on these problem areas, collaborating with people. So I would not give that up for anything, and I think many of my colleagues would agree with that as well. So I think my sense is that we have the better case by far, and yet, I would say it's also the case that we haven't won the day. So what does that mean? We haven't won the day. Here we are at a faith and science conference, and I say gauging the success of intelligent design. That's the title of this talk. And the word success can be a weasel word. I mean, there are lots of things. You can be highly successful at making money, but if you lose your family in the process, have you been successful? You put what is it, the old metaphor about putting a ladder on a wall, and you can be successful at scaling that wall, but was it the right wall that you scaled? Jesus on the cross, was he successful? I would say yes, in redeeming humanity, but the Pharisees and Sadducees and Romans who crucified him probably would not have regarded him as successful. So I do think that we have been successful in the intelligent design movement at uncovering the truth of design in nature and giving it scientific teeth. I think that's been important. So it's not just that we're doing this as a science versus religion or religion versus science controversy, that there's real solid evidence, scientific evidence for design in nature. So we can take it to the scientific community there. It's not just that we have to cite a Bible text and say, oh no, evolution can't be right because Genesis teaches that it's not. It's no. Darwinian processes don't have the power to create these sorts of systems, and we can show you why it breaks down. Why the math doesn't work, why the evidence from biology doesn't work. So in that sense, I think we've been successful. But I think in a broader sense, we still have a lot of work to do. I remember one professor of mine of statistics, he said, it's one thing to have a good idea, but then you've got to sell the idea. And I'm these days I'm a businessman. I work actually in the educational technologies, and I'm doing that in part because I think intelligent design has not succeeded as well as it should on the educational front. So this is one of the things that motivates me there. So success of intelligent design. If I imagine myself back 25 years, I would have seen it along the lines of how quantum mechanics won the day within a decade in the 1920s and 30s, and then there were Nobel Prizes given for quantum mechanics, work in physics, and the whole physics worldview changed. That hasn't happened with intelligent design. I think we keep winning people here and there, but as a culture, it seems that there still remains just vast resistance. And let me give you just a sense of that. Mike Behe, perhaps the most prominent biologist in the intelligent design community. You go on the Lehigh University website, okay, and it's got a department position on evolution and, in scare quotes, intelligent design. The faculty in the Department of Biological Sciences is committed to the highest standards of scientific integrity, blah, blah, blah. Okay, we're really, all for science. The department faculty then are unequivocal in their support of evolutionary theory, which has its roots in the seminal work of Charles Darwin and has been supported by findings accumulated over 140 years ago. The sole dissenter from this position, Professor Michael Behe, is a well-known proponent of, quote, intelligent design, close quote. They don't put the scare quotes around evolution. While we respect Professor Behe's right to express his views, they are his alone and are in no way endorsed by the department. Well, you see where that's going, right? I mean, can you imagine doing that? the situation being reversed or doing that with any other scientific view. I mean, here he is singled out, and he's fortunate. I mean, at least he wasn't forced out of his department. Let me give you the Wikipedia first paragraph, and these on intelligent design. Intelligent design is a pseudoscientific argument. Okay, we got to get that word pseudoscience in there, first thing, for the existence of God. Now, design is looking at patterns in nature. Where did they come from? Well, they could come from God, but there's an atheist I know, Thomas Nagel. He's a professor of philosophy at NYU. He holds that there's teleology in the natural world, but doesn't hold that this is the result of any sort of personal, ethical, monotheistic God. I've spoken at the Oxford Center for Hindu Studies, and they are not traditional theists, and yet they embrace intelligent design. So it's really, with intelligent design, anybody who holds to some sort of purposiveness in the world could be open to this. Okay, presented by its proponents as an evidence-based scientific theory about life's origins. Yeah, okay, that's right. Proponents claim that certain features of the universe and living things are best explained by an intelligent cause, not process of undirected of natural selection. ID is a form of creationism. Okay, now they have to get that in there because creationism does refer to a creator God. Intelligent design is not saying that there is a creator God. If there is a creator God, that God would be a designer. But design, how the design got in there, if you look at these structures in biology, the DNA code, and you say, okay, there's an intelligence behind that. But how do you get from the intelligence that's there? I think that's a reasonable inference by looking at the genetic code saying that there is an intelligence behind it. But to go from there and say, that has to be God, that's going too far. How do you go to the infinite, personal, transcendent creator God of Christianity from finite material arrangements of things? Immanuel Kant saw this 200 years ago. He saw the design argument as legitimate. It's just that you couldn't push it all the way to the deity, but that there was still evidence of design. So, so I've thought, well, I'd like to edit that, show them what's really going on. But if you know anything about Wikipedia, it's very tightly controlled. I can do some edits. In fact, I was thinking of trying to do some edits just as an exercise for this talk and then showing how quickly they'd get changed back. But the thing is, I use a certain login and password, and I actually do. There are places in Wikipedia where I can make a difference, and I just don't want to mess with it. But I think this gives you a sense of where the culture is, and here we are. I mean, this conference is sponsored by Discovery Institute. Discovery Institute is the key place for intelligent design. And we've made good inroads. We've published good stuff. We've gotten access to good publishers. Discovery Institute, there's an algorithm that I helped create on gauging influence. And Discovery Institute, according to that algorithm, is the 43rd most influential think tank in the US. With thousands of think tanks, that's actually not so bad. So, I mean, we've made a lot of inroads. We've gotten people's attention. And yet there's a sense in which winning the culture, we're still a long way from that. And so in closing, let me give you, there's a New Yorker cartoon, and it shows an attorney across the table of a client, and he says, "You have a pretty good case, Mr. Pitkin. How much justice can you afford?" And I think this really does get at what we're dealing with. It's one thing to have the good ideas, but you still got to get them out there and get them out there in a way that can be received. And I think we face tremendous opposition to this day. I'm still optimistic. I think we've got the better case, but it's going to take more than just patting ourselves on the back like, hey, we've really made a good argument. Okay, so how do we get this out there so that people actually can receive it? Thank you.